Okay, let's go. So, um, the official title of this talk is Phylo-birding, and that's a name I invented. It's how you can use the phylogeny of birds and the biogeography of birds to enrich your birding experience. And there will be 2 phyllo-birding walks from SCVS, and if they haven't been all signed up yet, I encourage you to try that so we can put this into practice. All right, so phylogeny and biogeography, that's the key here. As we'll see a little while, phylogeny is the key to biogeography, so it all follows pretty well. I don't know how much you guys know about either of these terms or the practice thereof, but I'll try to be gentle. So it's going to start. Okay, I may have to click through this manually. Anyway, if you ever took a biology class, presumably you're familiar with the class, order, family, genus, and species in classification. I want to introduce one more. In between order and family is the superfamily. And a superfamily is just a bundle of families. This is especially useful when talking about the songbirds, passerine birds, because there's just so many of the families. It's nice to have these bundles, and that's where we'll concentrate later. Beyond that, we want to talk about the families of birds. That's the basic unit that I'd like people to think of. Anytime you see a bird, you should also think of the family that it's in, all its little connections. For example, and I keep on trying here. I'm going to have to move a window around. Okay, there we go. So the class is aves. That's just the birds. That's pretty simple, and we don't really have to think about that much. The order in this particular case is Passeriformes. All orders end in the letters iformes. That's how you know it's an order. Here's the superfamily Corvoidea. All the superfamilies names end in oidea, so you can know that's what those are. Family Corvidae, all the family names end in id, so again, you can tell that. In this case, we have a genus, Cyanocida, and a species, Cyanocida stellari. You don't have to worry about that too much, but put them all together. Oh, it's not working again. Why is my, okay. Put them all together, they spell Stellar's J. So it's very useful to know at least that Stellar's J belongs to the family Corvidae, the crow family, and above that, the superfamily Corvoidea that includes the crows and a whole bunch else. On to phylogeny. So this is a tree showing the birds that you find in, we're going to call it North America. I know Mexico is part of North America, but US and Canada, not including Hawaii. That's what we call North America around here. And these are all the families. They're kind of small to read. Sorry, but that's the only way they'd fit. And this is a tree, a phylogenetic tree showing the relationships among these families. If you look up here, this time, this tree is oriented toward the right. Some trees will be oriented up and down, but you can tell the direction because all the names are on one side. And that's the present day. And if you go, in this case, toward the left until you get to the very end of the tree, that's called the root. That's where everything comes together. In between, various branches connect to each other, and that's the place where one or more families finds their common ancestor. So if we can all read trees, here we have the tree of American families. And here's the tree of worldwide bird families. It's a lot bigger. It's so big that even in small print, I had to fit it in 3 layers. Right? So here on the left, this tree connects to that spot, and then this tree connects to that spot to make one giant tree. And it is a giant tree. The purpose of showing this tree is to point out how few families we have around here compared to how many families there are in the world. Right now, the tree here is shown in green on the big tree. I would like to point out that phylogenetically speaking, we don't even have half the tree. If you look down at remember that's called the root. One branch goes this way, one branch goes that way, and the branch that goes this way, which is the flightless birds like ostriches and emus and such, does not appear in North America. Here's another example. These are 2 orders, Carassiformes up here, Pisciformes down here. Carassiformes has 6 families in it, but of those 6 families, only one, the kingfishers, appears in North America. Similarly, Pisciformes has 8 families, but of those 8 families, is it 8? Now I have to count again. 1, 2, 3, 4, 5, 6, 7, 9 families. Sorry. Of those 9 families, only one, the woodpeckers, appears in North America. Right? About half the tree, a little more than half the tree, is one order. The Passeriformes, or the songbirds, that's what those red arrows are showing. And you will notice that the greenness is pretty sparse in most of that tree. What we see is a small sample of the world's birds. I'm going to spend a lot of my time talking about the Passeriformes. So let's switch back to North America. I want to get a few terms down. Right? So the Passeriformes in North America come out of this branch. So all this stuff with the colors, that's the Passeriformes. Okay, let's call them songbirds for now. And there are 6 superfamilies that I would like to impress into your mind. Off to a bad start because this superfamily isn't really a superfamily, it's a suborder, but don't worry about it. We'll pretend it's a superfamily. It's called the subacenes. Notice it doesn't end in oidia because it's not really a superfamily, but go with me, right? The subacenes, as far as we're concerned in North America, include just 2 families, the flycatchers and the titiras, of which we have 1 species, barely gets into North America, rose-throated Bacard. Then another superfamily, this one's a real superfamily. This is the one Corvoidea that the Steller's jay is in. It includes the crows, the vireos, and the shrikes, at least as far as we're concerned here. A third superfamily, a pretty big one called the Sylvioidea. It includes a bunch of families, including the chickadees, the bush tits, the swallows, and in this case, the wren tit, and a few others. Notice that I'm going to skip over some because I want to concentrate on the main superfamilies. This next superfamily here is the Muscicapoidea, and it includes some common stuff that we see a lot of, thrushes, thrashers, starlings. By the way, the starlings are in gray because they're an introduced species. Then next we get the Certhioidea. Certhioidea, most of the families, and that can be found in North America. It includes a lot of little insect-eating arboreal birds like wrens and creepers, gnatcatchers, nuthatches. Final superfamily is, at least around here, the biggest one. It includes a lot of finchy-like birds, and among the birds it also includes is a subgroup that I want to emphasize. It's called the New World 9-primated oscines, which is a big name. Let's unpack that. First, New World, because these birds are present in the Americas. 9-primaried because the primary feathers are the ones that attach to the fingers of the bird. And most birds have 10 of them. These guys have 9. And there's oscines because oscine is the biggest group of songbirds that all of these superfamilies except the suboscines belong to. Right, so New World 9-primated oscines, very prominent around here. They include the sparrows, the cardinals, tanagers, the warblers, the blackbirds. So a lot of the birds you see are New World 9-primated oscines, and even a few more of those are passeroids that are not 9-primated oscines. So everybody remember all those things. The color coding is going to be maintained for a while. Now let's look at the world. So here are those same groups mapped onto the world tree of passerine birds. And you'll notice that a lot of them got a lot bigger because just like everything else, the United States, North America has a fairly small sample of the world's bird families. Notice especially that the suboscines went from 2 families to a big pile of families. Notice that the corvoids went from 3 families to a giant pile of families. The sylvioids more than doubled in number of families. Even the passeroids, which are the #1 New World group, have a big increase in families. Muscicapoidea and Certhioidea haven't changed a whole lot. They're real North American guys. So how do we know any of the stuff we know about biogeography? And this is going to get into the biogeography. And I want to talk about biogeography of passerine birds, the Passeriformes, for reasons that I'll explain in a little while. But here is the history of the migrations of these birds. Now they start out, and this is a map of the world about 30 million years ago when a lot of this stuff is going on. They start off down here somewhere in the southern hemisphere. I'm assuming that they began in Antarctica, which at the time was free of ice and was just fine for birds to hang out. What we actually know about this is that a lot of the birds were found in Australia. But let's go with Antarctica. It makes a lot of sense because the first migrations that happen are from somewhere down there in the south. First, some of the birds get into South America. Those are the New World suboscines, if we're keeping track. About that time, they may already have been in Australia, but soon after this, somebody gets from Australia to Asia. And at this time, it's a pretty long trip, so not a lot of birds have actually made that trip. Then from Asia, birds start going all over the place. There's two routes into America, right? Across the Atlantic, across the Bering Strait. From Eurasia, it's a short trip to Africa. From North America, it's a short trip to South America. And all these routes have been used by a lot of birds. The question is, how do we know any of that stuff? Here's where the phylogeny comes in. All right, so here's another tree. This is a tree of the Passeriformes, the passerine birds, and it's been color-coded by where we think these families started. And if you take a look up at the top, right, this is where we think the current family started. And then if you follow it down, every time a branch joins another branch, we get some sort of impression of where that branch starts out, right? So because all the birds up here are found in South America, we assume that one migration into South America is enough to explain what's going on up here, and so on down the tree. Using the tree and where things are now, you can get some idea of where things were a long time ago, all the way down to the bottom of the tree. The parrots are actually on this tree as what's called an outgroup. And notice all the parrots begin in what we're going to call Australia. Again, Australia, Antarctica, somewhere around there. And the passerine birds clearly begin. Oh, great. I have to reopen this for some reason. PowerPoint does not play well with Zoom.
Yeah, unfortunate.
Come on. Let's go. We're opening up. Here we go.
So while John's getting his screen share back up and running, I did want to mention there are still some spots open for the May 19th and May 25th trips. So if any of you want to bring some unwitting friends along to teach them science and the joy of birds, there are openings. It doesn't have to sound quite as sinister as that.
I think we're back. Are we back?
We are back. Thank you.
Okay. Let's see if this ends up working for the rest of the show. Okay. Now we have to find our spot. Moving right along. Remember all those? Okay, here's the back to the tree. What I want to do is talk about all the superfamilies, which are marked at the top of the screen here, and how they got there, and a few other fun facts. All right, so again, the passerine birds start out in Australia. That's the red thing. Early on, they split into two pieces. Again, this is one species goes one way, one species goes another way. And one bunch over here, the subacenes, right? And over here, remember those guys, the acenes, the New World 9' acenes are over here in the purple. So the subacenes are kind of interesting because remember one bunch immediately goes into South America. That's these guys, the New World subacenes. And one bunch ends up making that trip into Asia. That's called the Old World subacenes. Let's look on close up on those guys. Okay, here are the subacenes. Also might note this one little family here called the New Zealand wrens. Surprised they're in New Zealand. Presumably they've been there for a long time and they got there from Australia when Australia was a lot closer to New Zealand. You may, if you've ever been to New Zealand, you may know the rifleman. That's the New Zealand wren. Then here are the Old World subacenes. They start out in Asia. Some of them go to Africa. The Phylo-birding, those are the acetes that live in Madagascar. These are the broadbills. Do I have a picture of a broadbill? No, I don't. Sorry. Notice that one of the Old World subacenes got into South America. It's the only Old World subacene in the New World, and that's called the sapioa. If anybody's ever been to Venezuela, you might find one there. This is a typical Old World subacene. That's a pitta. Then we have the New World subacenes. Right? They're taking a different route. The Old World subacenes go from the south. The New World subacenes came around through North America and down into the south. What am I thinking? I'm making stuff up here. The Old World subacenes went over this way. The New World subacenes went down from the south. And they are a big bunch. Again, the only thing we have around here are the flycatchers. There is, again, one member of the Titira family, the rose-throated Bacard, but everybody else is in the neotropics, which we're going to call Central and South America. Here's a cotinga, cock of the rock. That's an ant pitta, anything with ant in the name. An ant bird, some oven birds, and wood creepers. All these guys are the vast New World subacene group. Over here is a bunch that don't get a name because they're not a group. There's a bunch of different birds. All of them started out in Australia. They're all still in Australia, but they're in between the subacenes and the corvoids. So take a little look at them. We have a bunch of Australian groups. And by the way, New Guinea is part of Australia as far as geologists are concerned. So some of these birds are New Guinean, but we have such things as lyrebirds, bowerbirds, Australian wrens. There's a superfamily Melophagoidea, which has a bunch of families in it, like the honeyeaters, the Australian wrens, and the thornbills. So if you've ever been to Australia, you'll find a lot of these birds, and that's the only place you'll find them because they never got out. Okay. Then there's this big superfamily Corvoidea that includes the crows. As you can see here, most of the corvoids come from Australia. Most of them are still in Australia. A few families have got out into Asia, and a very few families have got as far as America. One family supposedly, when I made this slide, I thought that the vireos had originated in America. Turns out they didn't. Here's a vireo. Most of the vireos are in America, North and South America, but it turns out there are recently discovered a few species of vireos in Asia. So the vireos actually come from Asia. Take the blue off the slide right here, turn it into orange. This guy is called what's it? I'm trying to work on it's Teruthius. That's the Latin name. A shrike babbler, but it's really a vireo, as we've discovered. Lots of other families in Corvoidea. Fantails are very common. This is an African family. This is a gonolek. Again, most of them are still in Africa, are still in Australia. The other two families that made it into North America are the crows and the shrikes. Continuing the story of Australia, because everybody's still in Australia at this point, we have another little group here that's not really a group. It's just a bunch of things in between the corvoids and the rest of the birds. As you can see, they're almost all in Australia. All of these families, except one, are probably originated in Australia, and most of them are still in Australia. Some of them have, again, escaped a little bit out of Australia, but they're almost all still there. Such prominent families as the Australian robins, some New Zealand birds, the New Zealand wattlebirds and stitchbird are corvoids. Sorry, not corvoids, but in this intermediate between the corvoids and everything else. There's a single species, the eupetids. They're in Asia. There's one little family called the rock fowl that comes from Africa. How did they get to Africa? That's the farthest anybody in any of these groups ever got. We don't know. Finally, we get to most of the superfamilies. And here's a very important point on the tree. At some time in the fairly distant past, perhaps around 30 million years ago, as shown here, one species of birds got from Australia and flew to Asia. Could have been one single event where a migrating flock got blown off course. We don't know what happened, but we know that it happened once. And from that flock of birds, almost all the birds in the rest of the world outside Australia descend. And so here's the crucial point in red. And you can see there, everybody's now in Asia. From there, some of them spread to Africa, some of them spread to North America, and some of them eventually get as far as South America. This is a big deal. Don't have much more to say about it, but that's a crucial event in the evolution of the passeriform birds. And right, almost the only birds that end up getting into North America come out of that one bunch there.
John, I've got a quick question. How do you know that it was a single event?
It's a single event because it shows up at one spot on the tree.
Okay, so we've got one genetic marker that y'all are looking at, or
this tree comes from a whole bunch of genetic markers, but they agree on this thing, so that's pretty handy. But yeah, it's all from genetics, and the fact that everything goes back to one point tells us there is one species that did this maneuver. Now, it may be several flocks got up there, but those flocks all apparently belong to this one species. Don't know what that species was, right? It's been gone for perhaps 30 million years, but a big deal. Let's go into now the superfamilies that descend from that brave or possibly just unfortunate flock of birds. I want to talk about the sylvioids first. Sylvioids have a bunch of families. As you can see there, they originated in Africa from that bird that migrated to Africa from Asia. A bunch of them have gone back to Asia. And there are perhaps a third of the sylvioid families are present in North America now, but none of them originated in North America. Sylvioids you may think of include the babblers, which currently has been split into a bunch of different families that all say babbler on them somewhere. Bulbuls, you may remember the bulbul that was hanging around Santa Clara recently. That's an escaped cage bird. The larks. This is a silver-eared messia, belongs to the family Laeotrichidae, which has some kind of a common name, but I can't remember what it is. These are the parrot bills, Paradox ornithidae. Things you'd be more familiar with around here are the swallows, the chickadees, the wren tit, bush tit, verdin. And if you go to Alaska, you will find the leaf warblers. That's an Arctic warbler there. There's an interesting story behind these guys, so I'm going to digress a bit and get into that. All right. So again, the families found in North America are in blue. So you may think that's a pretty good sample of the Sylvioidea. But of those families, only 2 of them have more than one species here. And that's the swallows and the chickadees. All the other Sylvioid families found in North America have a single species each. Start with another one here. This is the sole South American Sylvioid family. It's called Adonocobius. There's one species. Presumably he got there from Africa at some point a long time ago. Maybe he got into he hitched a ride on the same boat as the Sapioid did. At any rate, that's a South American one. That's one species. Here are all the North American groups. Right. So the wren tit on the left is the only American representative of the family Paradox ornithidae. I call it a sylviid here, but that's because after I made this slide, they split the family into 2 pieces. And the wren tit goes with the parrot bills. Again, one species of bush tit, one species of phylogeny warbler, the Arctic warbler, and that's just in Alaska. I don't even know if we want to count him. One lark, one verdin. But worldwide, there's 69 species of Paradox ornithid birds. There's 11 species of long-tailed tits, which is the family that the bush tit is in. There's 80 species of phylogeny warblers, of which we have 1. There are 93 species of larks in the world, a lot of them in Africa. We have 1 species of lark. There are 11 species of the family that the verdin belongs to, penduline tits. We have 1. How did these things get here and why only those? We don't know. It's pretty clear that the reason there are lots of swallows here is that swallows migrate very long distances. They get around. They're all over the world. But why larks? Why only 1 lark here out of all the 93 species of larks? Biogeography only takes us so far. I have more questions than answers for you, but I think it's just fascinating that we have our 1 lark species out of all the species there are. Okay, next bunch. There's few enough of them that I get to put them on one slide. The superfamily Muscicapoidea and Certhioidea, and there's a third superfamily that I have room to put on this slide now. Right. The Bombyceloidea we'll get to in a minute, but I want to talk about Muscicapoidea. They include the thrushes that we have. They include the thrashers, and the thrashers are the first American originating family we've seen. So they are all in the Americas, and they started in the Americas. There's a couple of African families. The oxpeckers and the starlings are mostly African. We have one species introduced from Europe. They also include the dippers. It's named after this really big family, Muscicapidae. And okay, I cheated a little bit. There actually are a couple species, but they're only in far north Alaska. So I'm leaving them off. This is another huge family, hardly represented around here. Before I get to more fun stuff about the Muscicapids, I want to point out the Certhioidea. Certhioidea is a largely American family, even though most of the families apparently start out in Eurasia. But we have two actual American families, the gnatcatchers and the wrens. And the wrens are kind of a reverse Sylvioidea because there are 80 some species of wrens in the New World, but there's only one species of wren in the Old World. So we get something out of that. The Certhioids are a bunch of tree-dwelling insectivores like the nuthatches, the gnatcatchers, the wrens. I don't have a picture of a creeper, but imagine a picture of a creeper. Final superfamily is Bombyceloidea, represented here by a silky flycatcher. And there's an interesting theory there. But I want to start by talking about the family Turdidae, the thrushes, specifically the genus that gives it the name, the genus Turdus. We have one species of the genus Turdus, Turdus migratorius, or American robin, but there are 86 species of that genus. It's a huge genus in the world, and the distribution is kind of interesting, right? So here's our one robin. That's the only one in North America, not counting a couple of things that get into the bare south of the United States. There's 14 in Central America and the Caribbean, a whopping 26 species in South America, bunch of species in various parts of the Old World. None in Australia, just like to point that out. So we're a little better than Australia, at least. So this is a puzzle. Why all these species everywhere, but only one here? And I don't have an answer, but I recently have found a little bit of an answer. The way the genus Turdus got here is directly from Europe, probably from Spain, into the Caribbean. And that one species diversified into a bunch of Caribbean things, found its way into South America, and diversified into a whole bunch of South American species, and one found its way into North America and didn't do anything. Now, why? It might be because this just happened recently. Maybe the robins haven't been here very long. I haven't checked that. Or it may be that having come to the Caribbean, these birds became accustomed to a tropical life and couldn't adjust to temperate North America very well. Then again, there are some species of Turdus down in Patagonia. So grasping at straws here. I just find this an interesting thing. When you look at a robin, think about that. There's 85 others very similar to it elsewhere in the world, and here we have the one. On to Bombyceloidea. Okay, this is superfamily is named after Bombycillidae, the waxwings. And they have an interesting story too. So here's the distribution of the waxwings. There's 3 species, different parts of the world. Another group of Bombycillidae are the silky flycatchers, 4 species, all in Central America. One of them gets up around here a little bit. That's the Phainopepla. The rest of them get weirder. This is the palm chat, family Dulidae. It's 1 species. It's found on the island of Hispaniola, no place else. This is a species called the Hypocoleus, 1 species. It's found in the mountainous Near East, Iran, a bit of Turkey, a bit of Iraq, and no place else. This is the genus Hylocytria, 2 species found on the island of Sulawesi in Indonesia, and no place else. And finally, this is the OO, family Mohoidae, found, well, not found anywhere because it's extinct, but until around 1950, there were a few of them still alive in the Hawaiian Islands, nowhere else. It was originally thought to be a Hawaiian honeycreeper, but that pesky DNA proved that it's a Bombycilloid instead. So look at this. These are 14 species comprising a superfamily that covers the world, and that's all there is. What this tells me is that there were probably a whole lot more species of Bombycilloidea elsewhere all over the place. And they've fallen on hard times and remain mostly in little islands isolated in the middles of oceans. That's weird. And I find that just very interesting. Okay, last superfamily, Passeroidea. These are mostly a bunch of finchy kind of birds. The arrow marks the entry of these birds into North America. That's where the 9 primary New World oscines come from. And we can also see right up here, at some point, one of these 9 primary oscines found itself in South America and just went wild. Let's check that out. All right, so definitely the passeroids originate in Asia. A lot of them are still in Asia, Europe and Asia. One family somehow finds itself in North America quite a while ago. That's the Pusidrammidae. We know that as the olive warbler, a single species in the far southwest. It's not a warbler. Its closest relatives are, well, most of the rest of the passeroids. It's out there on a long branch by itself. Conceivably, it's related to the dunnocks of Europe. And then later on, again, another bunch finds themselves in North America, give rise to a bunch of family. The finches Fringillidae, including goldfinches. Euphonias of the neotropics. Bunch of other things. Here's an actual North American family, the New World sparrows. Passerellidae. Do I have a New World sparrow? Yeah, there. Orange-billed sparrow from South America. Then we get the group that finds it into South America, and they consist of some really prominent stuff. Now, these are small families, most of them found on Caribbean islands, and it quit again. I thought we'd made it all the way through, but okay, here we go again.
We're getting super close. If you wouldn't mind While you're setting that up, we did have a question regarding the
Sure.
continental drift.
Hmm.
So obviously we're not talking Pangea supercontinent. But how much closer together were the continents when we're talking 30 million years ago?
Well, that picture that I keep showing,
Mhm.
that is 30 million years ago,
Awesome.
approximately. So that much I can give you. Of course, they've all been moving, and when continents run into each other, it can be complicated. If you look here, let's get this bigger. Hold on while I. All right. If you look at India, India is shown as separated by a narrow sea from Asia, but it's been piling in there for a long time. Supposedly, it first made contact about 30 million years ago, and uh, as you can see, sometimes the contacts can be underwater for a while. But India is still moving that way. That's why we have the Himalayas. You
Mhm.
can see the Himalayas forming right here. Australia may actually have had land contact with Antarctica until uh, as recently as I think it was about 35 million years ago is the last land contact. Uh, Same thing. There's actually possibly a land route from Antarctica through South America, or at least very short stepping stones up until around 30 million years ago or so. Uh,
Awesome.
Matter of fact, there's one Australian marsupial in South America that is theorized to have come around 35 million years ago.
May I ask
All
a
right,
question while you're on the map?
sure.
To me, it's like, why didn't any birds go straight to Africa? Africa is
Hmm.
closer than Asia in this
Yeah.
map. Do we know the answer to that?
Nope. Can't tell you a thing.
Okay.
Um, it may be that this event here didn't happen at this time and happened a little time later when Australia got closer. I'm presenting a snapshot of a thing that happens over a long period of time. That may not be the right snapshot for this arrow here. Okay.
Thank you.
Let's try. Yeah, but why is always hard to answer. It's the best I can do to say what happened, but I cannot find it hard to say why things happened or didn't happen. And where am I trying to do? There I am. Okay. Um, where's my slideshow? There I am. Okay, and now I have to swap displays again because it keeps going back here. And now I have to move along at high speed. Remember all those birds? There they are again. Okay, last bunch, Passeroidea. Um, I like to make special note of the birds that got into South America. Again, here is uh, I'm not showing you anything right now, am I? Laser pointer. Um, Over here is where all the big action is happening, right? Because these birds that originate in South America include the blackbirds, the warblers, the cardinals and grosbeaks, and especially the tanagers. Tanagers are the second biggest bird family. The biggest bird family is actually the flycatchers, but they are crazy in South America. They are really wild. Here's a tanager. That's a paradise tanager from South America. You may think of this as a tanager. That's a summer tanager, but of course, summer tanagers aren't really tanagers. They're cardinals. There are no tanagers in what we're calling North America, except for one that just barely makes it into South Texas called Morelet seed eater. Uh, Here's another tanager that's not usually called a tanager. Right? That's a honey creeper from the neotropics. Uh, At least half of the tanagers aren't even called tanagers, but Darwin's finches are tanagers. All kinds of birds you find down there are tanagers. Some of them are called finches. Some of them are called lots of things. Here's a nice blackbird, an oripendula. Of course, orioles are blackbirds. A warbler. All these guys originate in South America and end up in North America probably fairly recently. And I think that's a big story too. Should also mention all these other passeroids out here that are not American. All right, the majority of families are not the majority of species, thanks to the tanagers. We have the Astrildid finches, right, from Africa, Asia, and South America. You may think of the Munias that are found around here now, having been introduced. These are the weaver birds and the bishops from mostly Africa. Occasionally we get these guys nesting around here. These are what in Africa and the rest of the world passes for hummingbirds, right? These are the, I keep blanking on common names. Sunbirds. Lots of sunbirds. They act like hummingbirds, except they tend not to hover. They perch. The fine fella here is a paradise whita. All sorts of finchy birds. Old world sparrows, of which we have a couple species here having been introduced. So Passeroidea is a big group, but it is perhaps the dominant group of songbirds in the Americas, largely because they got into South America and went crazy. Some of them make it back here and fill up our bird fauna. So if we go out walking around, I'd say a majority of the songbirds we find are going to be from the New World 9 primary Oscenes, and a majority of those are going to be from the from this South American bunch. And that concludes the slideshow. Which is good because we don't have time for this to crash again. Okay, now we're open to questions and any time left over. This was supposed to be about an hour.
Yeah, so we've got a
Do
little
we-
bit of time for a couple of questions.
Okay.
We did have a question about the bird populations in South America around the Brazil area.
Mhm.
So you have from what I've gotten is there were like two distinct lineages that arrived in South America, correct? We
Yep.
have
Take a look here, right? So we have we have the New World suboscenes, right? The flycatchers and all their many friends that we don't see here. That's first. They were there for a long time before the other bunch showed up. Again, these don't actually have a name, but they're the bulk of the New World 9 primary oscenes. That presumably came down from the north.
Mhm.
Of course, there's the Sapioa and the Donacobius, whose arrow is not shown on here, that presumably flew in directly from Africa. So this fauna has been assembled in a number of ways, but the two big arrows are the dominant ways they got there.
Okay, so we got the rheas and then we got all of the songbirds coming in.
Yeah. So the rheas, we got no clue about how the rheas got there. But the theory is that their ancestors flew in and then decided to stop flying.
Okay, yeah, that does seem to be how all the ratites ended up developing is they liked it there and decided flying is fun.
Who needs wings?
Nah, that's why you just get really big talons on your feet. Just kick everything. All right. If anybody in our audience has any questions, you are welcome to chime in. Otherwise, I'm gonna pick John's brain about why they thought we needed an Icteridae and Icteridae family.
Ah, okay, Icteridae is um, is the is the chat, right? That's the only species in the whole family.
Okay.
And we used to think it was a warbler. It's not a warbler. We're not 100% sure what it is, which is why it gets its own family, right? It would be logical if we considered it to be, considered this tree to be absolutely true,
Mhm.
right? That would make it into a blackbird, and we could get rid of the family. But it's not 100% certain, right? I have to tell you that not everything on this tree is 100% certain. But I'm just presenting it that way. It may be that the chat is actually more closely related um, to cardinals than it is to blackbirds. We're
Oh,
not 100% sure. So it gets its own family because that's the easier way out.
yeah. Makes it a little bit easier to reorganize that taxonomic tree, I guess.
Mhm.
Right. Excellent.
John, at the beginning, you were talking about Coyote Ridge, and I was just looking on the Audubon Society website. I don't see any Coyote Ridge listed under the, self-guided tours. Can you just give a little more information about where that is so we can find it?
Um, I don't think it is, right? We don't have any because Coyote Ridge just opened last August.
Yeah,
Uh-huh.
we haven't gotten the opportunity to have a self-guided field
Um,
trip written
but
up for it.
but there's a real easy self-guided tour. You go there, you park in the parking lot, and you go around the 5 mile loop trail. That's all you got to do. And most of the good birds are up near the top too, so you want to hike some distance. If you want a guided trip, go to the Open Space Authority website, and
Okay.
you can sign up for they're currently they're wildflower walks, but believe me, if you see birds, they will not be ignored.
Okay, so I just Google Coyote Ridge Trail and that's it?
Um, it's not called the Coyote Ridge Trail, Coyote Ridge Open Space Preserve.
That's in La Honda. Am I in the right spot?
So,
No,
um,
No.
yeah,
that's
Dory,
that's
I just dropped Open Space Authority's preserve webpage
Okay.
in the chat.
that's what you want.
Okay. Thank you.
Anyway, by the way, Coyote Ridge is also called um, Mayano Yakma, which means Coyote Ridge in Chochenyo. So don't be confused if you see Mayano Yakma sitting around there.
OSA has been doing a lot of work with using the native languages in the area, which has been really wonderful.
That is wonderful.
Yeah.
Okay, I got it. Thank you so much to both of you.
For sure.
All right. All right, we've got a question from Patricia. She can't make it to the field trips, but would you mind describing generally how you'll be putting the phyllo-birding into practice?
It's pretty simple. We go around and look at birds, and after we identify them, we go that further step, figure out what family they're in, and think of interesting biogeographic things or phylogenetic things to say about them. Well, I guess mostly I think of interesting things to say about them. If anybody else has interesting things, that's good too. But I just want to start incorporating phylogenetic and biogeographic understanding into your birding. And it just adds a little bit more, like that whole thing about the robin. Believe me, we see a robin, I'm going to go into that entire spiel right there, because I think that's just weird. See a wren tit, right? Point out that wren tit is the only American representative of this big Asian group, Eurasian group. All that pretty cool. And we want to identify, right, We want to count up how many families we see, not just how many species we see.
It's kind of shocking to me that the wren tit is the only representative species from that, considering how little they actually move in their day-to-day life.
Mhm. Well, you notice it's also really far away from Asia.
Yeah.
Right? There's no wren tits in Alaska. As a matter of fact, most of those single representatives of the sylvioids are down in the Southwest somewhere.
Interesting. Some freak ancient storm or something. Yeah, I don't have any experience with genetic research, but in bird banding, whenever we do manage to capture a wren tit in the mist nets, you have to walk them back to the exact net that they were captured at. Otherwise, they get lost on their way back to their territory.
Okay, well, I can see how a bird that gets lost easily might find its way from Asia into America.
Yeah, that is true, but they stick so close to that one little patch of territory.
Yeah,
It's kind of amazing.
yeah. I mean, you would think that a migratory bird would find it more easy to end up in a different place.
Hmm.
But yeah, no explanation for how wren tits are here and not other places. That's just, I just marvel at the weirdness of it. That's really sometimes all you can do.
Yeah.
But it's fun to marvel at the weirdness of it.
Yeah, that's what makes things interesting.